All right, so I'm going to continue on here, and all right. Okay, so I've got I'm gonna create a new file inside of M8 here under C users George courses SPA M8. I'm going to create a new file, new text document. I'm going to call this example1.py. And then I'm going to right click on this, and then I'll have the data set that, then I'll have a Python file to work with. I don't know if they can hear me.
Hey guys, can you hear us?
Hey, can y'all hear or no?
Yes, sir.
Oh, okay. All right. So I've just created a new script in IDLE here. And what I'm going to do is do an example here of writing a script and show a few more concepts. You're welcome to come in and sit down, whatever. So okay. So I'm going to copy this example from the Euclidean distance tool. This is one of the tools that you'll have to run in the lab. So I'm just going to go ahead and copy that example into this script. So this will be up there as an example. But here they've specified a workspace. This workspace obviously isn't going to work for us, but we can specify the workspace where I put the data, and that was in C temp M8. So if you were to download this example, would you have to change this? Yeah. You'd have to change that to this particular directory. And wherever you put the data on your disk, you would have to specify that same folder. Sorry, did you have a question?
Right.
All right. Okay. So for the Euclidean distance, I'm going to choose the data set that we've been working with, which is the urban areas. I'll get the location of that on disk. So that's just called risk urban areas.shape. Now I'm accessing that. I think the first parameter was the cell size. No, that's the maximum distance. So I'm just going to turn that into quote, quote. And then the minimum distance method, the cell size is the next parameter. Now for the lab, I ask you to do a cell size of 50. So we need to just change this to 50. And then, yeah, we don't have any other, we're not going to do a direction raster or anything, so we can just delete this. All those others are optional. So what if I change this to outDistance.save and I just put in the name of a data set. Like I called this urban areas distance. Where's it going to save that to?
Wouldn't it save it to the workspace?
Yes, it will save it to the workspace. Good. All right. Now, there's a problem though. When you save rasters, just like when you save vectors, the location you save it to and the name imply what format you're saving it as. So when you save a vector as a .shapefile, it's saving it as a shapefile. If you put .shp on the end, it's saving it as a shapefile. And if you try to save a shapefile into a geodatabase, what do you think would happen? Maybe you've never done it, but what do you think might happen? Well, it's going to error in Python. It's not even going to let you save. So in other words, if I took a shapefile and tried to save it into a geodatabase, a .gdb, it would error out. The same thing is actually true in raster. If I take a raster, can you save rasters in geodatabases, by the way?
Yes.
Yes, you can. You can save rasters in geodatabases. So if I tried to take if I made a file called .tiff and I tried to save it in a raster geodatabase, it would freak out. It wouldn't let me do it. ArcGIS would say, no, you can't do that. Well, there are a few other rules. So if I try to save a raster without an extension, it saves it in a format called ESRI grid. It saves it as an ESRI grid. And ESRI grids were created a really long time ago. They only allow 10 character file names. And so this will actually error out, and you probably will end up like pulling your hair out going, why is that not working? Well, the reason it's not working is because urban areas distance is longer than it allows for. So I mean, I could even try to run this right now, and I'm pretty sure it's going to error out. I'm not positive, but I'm pretty sure because it doesn't allow for file names that are that long. Okay, so it says could not. It's actually more descriptive than I thought. Could not save raster data set to that location with output format grid. Remember, I said I was going to save it as an ESRI format grid. So what are some solutions that you could propose, knowing what you know about rasters, if you know anything about rasters? Let's think about.
Well, you can shorten the name, three characters per.
I can shorten the name. That's an easy solution. That's good. I'm going to tell you a few other solutions. One is you can save it in a different location into a geodatabase. If you saved it in a geodatabase, it would take that name just fine. Third solution is you could name it something, you could give it an extension of a raster format that will allow more characters. And a pretty common one is a .tif. So you could do .tif, and it will save this output raster on disk as a, what's a .tif?
I think it's
TIFF.
Yeah, a TIFF. Yep. Right, so now if I run this, it will work. It will save it on disk, and it will be a TIFF file if I go into where I'm dealing with. I refresh. Oh, it's right here. So here's my, what did I call it? Forgot what I called it. Urban areas distance.tiff. Urban areas distance.tiff. It's right there. Okay. So I could bring this up real quick. I'm gonna get rid of all these other ones that I don't really need anymore because there's examples. Remove. Remove. What was that one? Yeah, remove that one too. Okay, so now I've gotten rid of all these other things. So now I'm going to add that that data set that I just created, which was called, I'm gonna have to refresh, yep, which is called Urban Areas TIFF. So it's right there, Urban Areas Distance.tiff. Gonna add it. Now it has that same problem. It's not the entire area. It's just that little area. So how do I solve that problem in my code? How do I solve that problem in the code to make it so that instead of being the entire, instead of being just that little area, I get the entire area? What do I have to change?
Hey, is that error that you got two ships twice? Or is it?
What error?
Back to yeah, ship twice.
Oh, SHP. I didn't get an error. I'm not sure why, but you're right. I don't know why I didn't get an error, but I didn't get an error. Maybe that looks like it's probably a bug in the ESRI code that it allows you to put .shp twice. But it did run just fine and it worked. Okay, but the question here is what do I need to do? env.what to get it to be a different area that gets processed. You guys remember? The extent. Okay. And we could set the extent to be the same as the watersheds data set. So I could say is equal to that. And why do I not need to provide the full path there? Well, actually I do, unless I put it right here, which should give you a clue. So why don't I need to provide the full path?
Because it's already on the there.
Yes. So if there's no path in front of it, it will use the workspace path. So now when I run this, there's a small chance it'll error out just because, yeah, so because I opened it in ArcGIS, it's freaking out. So I'm going to go ahead and save it here in ArcGIS, and then I'll just run it again, and then I'll open ArcGIS back up to look at the extent. So cannot be overridden. Oh, sorry, that actually is a different error. So how do I solve that problem, that it can't be overwritten?
Well, you got to refresh it, right?
You put in your code override.
You put the override on.
Yeah, you gotta change the ship list, the name to something else, like worksheet one.
Yeah, so Ashley gave the right answer, and so did Ben up here. Overwrite output is the environment variable that we need. I always forget how to spell overwrite output, so I'll copy it out of here.
So you just couldn't change the output area? You have to put that statement in there?
Oh, I definitely could call this urban areas distance 2.tiff. Is that what you're saying?
Yes.
Yeah, I mean, if I wanted to compare it, I could do that. But if I want to actually be able to overwrite it, then that's what I need to do.
Okay.
Yes, you're absolutely right. I could have just saved it as a different file. Right? But if I want to actually save it over, or a third solution is I could have deleted the file. A third way to solve the problem. All right, now I'm going to take a look at it, make sure that it has the right extent. So I'm going to add, and here it is. And it is. It's the full extent now. That's exactly what I want it to be. So I've completed that. That script demonstrates outside of ArcGIS what we want to do. Now we actually want to do that. If you look at the lab assignment, what we want to do is take each of the shapefiles that start with risk. So we've done it with risk urban. We need to do it with all the other ones. Okay. Then we need to use the Euclidean distance to find a raster of straight line distance from each of those data sets. So we did that. That's where we are right now. So now we are at the point where we need to do 4, 5, and 6 to finish it off. Well, let's talk about how we do these, because these are part of the ones that I kind of skipped here before. I kind of skipped over a little bit up here, particularly the is null and the con statement. The con is really a really important statement. It's actually very similar to using if-then logic. And what it's useful for is saying, my raster has values that I want to change, and I want to change them based on a condition. So my raster has a bunch of 5s that I want to change to 7s. How do I do that? That's the con tool. If I have a bunch of rasters that represent 0 and I want to turn them into 100, I use the con tool. The con tool says, find values of this data type, of this value, and change them to this value. That's what the con tool does. And so you're going to need that right here. Set all negative values to 0. The conditional tool will take a condition, which is if the value is less than 0, and we'll set it equal to something else, 0. So we'll do that in a second. So let's talk about this one first, though. Subtract the values in the Euclidean output from 1,000. So using what we did before, how could we do that? We've got our out Euclidean distance. We don't actually really even need to save it until the end. So we're going to skip that step for now. So how could we take our out Euclidean distance and subtract it from 1,000? What's the code that we can do? So we could do something like this. We could say, yeah. Well, it could be any name. Is equal to what? What do we have to type to get this value to do this? Subtract the values in the Euclidean distance. This is just normal math, right?
Okay, right.
So we could just type it almost like we could type a math problem, and it would work.
9 minus 1,000. So Euclidean distance minus 1,000.
Euclidean distance minus 1,000. All right, now look at this, though. Subtract the values in the Euclidean distance from 1,000.
Oh, from 1,000.
So you're almost right, but what would I do differently?
So you put in
If I said
1,000 minus Euclidean distance?
if I said subtract 2 from 5, write that in the math problem. Subtract 2 from 5.
5
Yes.
minus 2.
Yes. Yes. So switch sides. Yeah, you were on it too, Elvis. So we're just switching the thing. So subtract a number from 1,000 is actually 1,000 minus that number. So we're going to have this value, and now I'm going to save diff as and we'll see what we got. We'll call this diff.tiff first. That's kind of a funny name. We'll try that out. We'll see what we got so far. So we ran diff. We got diff.tiff, and we'll look at the output. Look at what it looks like. Go. So now we've got a bunch of values, and instead of being values that go from 0 all the way through to to the furthest distance away, what do they now represent? They're those same numbers, but they've been,
This is from 1,000.
well, they've been subtracted from 1,000. So when a value that was 0 is now what?
Oh, like 900.
No, a value that's actually 0
Oh, it'll be 1,000.
would be 1,000. And a value that was 1,000 is now what?
Then,
0. Yeah. Value that was 1,000 is now 0. What if the value was 1,001?
Be an error, because it'd be a negative.
So it would be a negative. That's all. It's not an error. So anything that's further, like if I click out here, anything that's further than 1,000 feet, I actually get a negative number. Or 1,000 meters, sorry. Anything that's further than 1,000 meters, I get a negative number. And if it's closer than 1,000 meters, I actually get the, instead of the distance away, I get 0 all at the very edge, all the way up to 1,000, meaning 1,000 is the same as 0 used to be, so it's the closest thing. Okay. All right. So how do I change this so that instead of showing 0 and 1,000, how do I do this thing right here? Set all the negative values equal to 0. That's where the conditional statement comes in. It's one of the most powerful tools. So let's look at it. So the con tool, ArcGIS Pro. Just going to Google it. All right, so here's my con tool in ArcGIS Pro, and here's a code sample of how to run it. So I need to give it a conditional. That's how to run it. Let's look at the parameters, which are up here. I need to give it a conditional raster. A conditional raster can be an expression, or it can be an actual data set where anything that is true, in other words, not 0, and anything that's false is 0. Or I could just do an expression. So in this case, I could make my conditional raster be raster less than 0, and that will be a condition. And then I have the value I want to change everything that's true to, and the value I want to change everything that's false to. So these are the important things. I really don't need to worry about the where clause. It's optional. I could use it instead of the conditional raster, but let's not worry about it. Let's just look at these parameters. So I know, sorry, I'm tripping over all the open stuff here. So I know that I'm going to have my out con. My conditional raster is going to be the difference raster, and I'm going to say greater than, or sorry, less than 0. And then if it's true, I want the value to stay the same. So here, what should I put if I want it to stay the same? This is the true statement.
1.
No, that'll turn everything to 1. In fact, so diff, yeah. So if it's true, keep it as diff. If it's false, I want to turn it all to be zeros. So like that. So now I'm going to save, instead of saving diff, I'm going to save outcon, and I'm going to call this, I'll just call it contif, and I'll run this guy. Okay, now it's telling me it's not, doesn't want to save it in that location as a grid. I'm not saving as a grid. That's why it's called TIFF. Conditional. Okay. I don't know why it didn't want it to save it as con.tiff. I guess maybe that was a reserved word or something. Anyway, freaked out when I called it con.tiff. So I renamed it conditional.tiff and didn't have any problem with that. Okay. All right. So let's look at that. Refresh. Here's conditional.tiff. And yeah, and the values are still all negatives. And everything is 0 back through. Let's see. Everything is 0.
Anything that was positive all became zero.
Everything that was positive became 0. Why is that? Let's see if I did my thing. If diff is less than 0, it's almost like it's doing it wrong, right?
Can you flip the sign around to positive?
Yeah, I mean, I could flip the sign around. I mean, if that works, that's great, but I still don't know why it would work, right? Like, still a problem. Oh, maybe I got these in the wrong order. Let's look. This says the true raster. Yeah. To me, that doesn't make any sense. Oh, it's probably gonna freak out because it won't save it over. Oh, it did. Oh, it's because I got rid of it. Good. Add data, conditional, and now it's doing what we want it to do. I'll have to go figure out, because really, if difference is greater than 0, means that means it's positive, right? In my opinion. Then if it's true, give it diff.
Is it because diff is defined as
Oh,
a value away from?
no. I got it right. So if it's positive, keep it the same. If it's negative, make it 0. So in a way, I did have these reversed. See what I'm saying? So it's an if-then statement. If the difference raster is greater than 0, the true is to keep it the same. So in other words, if it's positive, keep it the same. That's exactly what I want. If it's false, in other words, if it's negative, assign it to be 0. So I would have had to switch these two if I left this like that. So either one will work. Your code can be whichever way you want it. That'll work for us. Okay. So what we need to do is run this multiple times so that we have it run for each of the inputs. Okay. All right. So I'm going to save. I'm going to call this. I'm going to save this as example 2. So for example 2, I'm going to take out the I'm going to take out all this part. By the way, you should probably move this 50 into a. When you run it, I would make it not be part of this and be part of the script. So env dot cell size, env dot. I'll just do that right here. Cell size is equal to 50, and just get rid of it here. Okay. So I'm gonna get rid of these guys and do a for statement. For okay. One thing that we might not have covered, but I think we did, is that there's a generic Python tool in ArcGIS called list data sets. So if I want to get all of the data sets in a directory, I can use the list data sets function. So what this will allow me to do is something like this. Here, let's just for now, let's just say remember, you have to do this to all the risk data sets. So I'm going to set this equal to a list. I'm going to call it data list is equal to that. I'm just going to print that. Oh. And run this. It should get this. Let's just see all the data. What happens if I just do that? All right, so let's read the help. So lists all the data sets in a workspace. Search conditions can be specified for data set name and data set type limited to the list that's returned. Okay, so the wildcard, which we entered, if no wildcard is entered, all values are returned. And we said feature. Okay. A feature data set is different than a feature class. Sorry, we want the list feature classes, not list data sets. Still the same parameters, wildcard and format. So list feature classes, not list data sets. If we say risk star, and then we'll just delete this because we want all of it. All right. Now we have a list of all of the data sets that start with risk. See, risk small scale agriculture and risk urban areas is in there. Okay. So how would we write a for loop that went through all of this data list? Yeah. I don't think for list in data list. I don't like using list as a variable name. Well, it's not just, it is reserved, but it actually would let us use it, but it's not a list. What is actually being returned? Like, what are the elements in this data list? What are they? What are these? They're not lists. They're strings, but what do those strings represent? Shapefiles, right? So we could say, what's that? Yeah, we could say for shape or shapefile. I like to say layer, maybe. It doesn't really matter what you put. So I'm just going to say print layer. So we're going to run this guy and see how it's just going to print each layer. Okay. All right. Now what if I did, I'm going to show you something that might help you. Out layer is equal to layer dot replace dot shp with dot tif. What just happened there? Like, what's that doing? What is this? What is this doing?
It changed the output layer file to TIFF.
Right. So it's remember, layer is actually a string, even though it represents the location of a data set. So this is a string function that replaces, whenever it sees .shp, it changes it to .tif. So now when I run this, I will get two names. This name that represents a shape and this name that represents a TIFF. So what I could do is use that to, this I could use to get, for my Euclidean distance function, I could get the right layer, and then this I could use to save the layer out once all the other functions had been run. So here, what we want to do is what the heck did I do? Sample 1. I named this file real weird. Let me go ahead and name it the right way.
So all your shape file will have an output value, that's equivalent and change the TIFF file.
Right.
All one.
Yep. Exactly. So your job is to actually mash up these two scripts. So really, you don't need to change anything here. So this part needs to happen inside the loop. And instead of risk underscore urban areas being the input, hard-coded in, what do you need to feed it?
Set parameters for the user to do it.
So since it's gonna be a point,
Each time through the loop, you need to find the distance from the features. So what do you need to feed it here? One time through the loop, it will be that. But one time through the loop, it's going to be, well, anyway. Yeah, I'm going to leave it there because at this point, like a layer, you should understand what's going on in a loop. And each time through the loop, you're getting a file name and you're getting an output. And so your file name is going to go right there. Your output's going to go right there. And then you'll be saving out every time this loops through. You'll be pulling in the name of the file and you'll be saving it out in another location. Okay. Anybody have any questions?
so can you just expand and just put a star dot chip with change? They really put the name of it in there. Put the star on ship inside that with do anything. Does that make any sense?
I don't think so, but maybe I'm not thinking like you're thinking.
Since the star is a wild card name on that ship. Oh, it doesn't make a difference. I guess it's not.
This returns a list of everything that starts with risk, which is part of the command, part of the assignment. Take each of the shapefiles that start with risk.
Right.
Yep.
Yep.
Yep, we're already doing that. That's the result. When this runs, we're getting a list of all of the ones that start with risk.
Right, I got you.
Now, what you need to do is inside this loop, you need to find the distance between the feature in layer and find the distance from the features in layer for the watershed using the UCDist tool. Then you need to run outcon. Then you need to, we need to run difference first. Run difference from 1,000. Run outcon. So to set all negative values to 0. And then finally save the output as out layer. Okay. Right. So all this is already, my point is all this is already being done right here. So you're just going to mash those two scripts up. Actually, right there. All that is equivalent to that. Okay. You just need to put in the right variables. And then, finally, at the end, you need to write you need to write into your script, adding them all together, adding all the results together. Add up each of these data sets and save the output. So in other words, you need to add up the result of,
Distance and all the clear distance, add them all together.
yep, the risk for urban areas, the risk for small scale, you need to add them all up. So in the end, you'll get, so we have it for the urban areas, but you'll need to add it all up for every single one. And you'll need to write that into the script. All right? But do you have any questions about the assignment?
So you said that was your example 1, example 2?
Yes, and I will, I'll push that to GitHub. Just right now, I do want to delete that. I made a file called, I'll show you, courses, SPA, M8. See this one I made? I named it something stupid. All right, so that's example 1 and example 2, and you basically need to mash those two up to create, and then write one more. You need to do one more thing. It may be more than one line of code, but it's not going to be more than 2 or 3 lines of code to add them all up. M8. So I'm going to commit that to master, and origin, push origin. Okay, hold on. File. Sometimes it makes me sign out and sign in. There we go. All right, so now example 1 and example 2 should be up there. If we refresh here, example 1 and example 2 are up there. So you'll be able to pull those down to start your homework from. All right, any other questions? I'm also going to upload the video, and so you'll have that as well, and I'll update the links while that's going on. All right, any other questions? Skype, where does Skype go? There it is.